this here is our function. F of x is equal to 2x minus 1. Okay? F of x, let's just say that's this axis, or y. I'm just going to say this is y, okay? Just right here. This is the axis. I mean, they call this the y-axis, but we're going to call it the f of x axis. This is the x-axis, okay? Now we can plot this easily by putting a value in for x in the function, because it is a function. So let's say f of 0. This is how we find, by the way, this is how we find the intercept, where the line intercepts. This is the x-intercept. So, okay, so from this we can tell, if you can't do the math in your head, I'll do this for you. This becomes 0 minus 1, which becomes minus 1, because anything by 0 is that. Okay, here we go. So this is minus 1. Minus 1, negative 1 is what we have for f of x. 0 is already what we put in for x, see? So we can plot them. So we can plot that here. We can say 0, 0 is x, yes. And y is negative 1, okay? All right? And here we have 0 on x and negative 1 on y. And here we'll place a dot to remind us. Okay, this is where we have the x-intercept, or the y-intercept. Now that I say it, this is the y-intercept. So if you solve for x and you do x is equal to 0, you get the y-intercept. If you do, let's say, how do we get y to equal 0? Let's see. We probably want to make this times, let me think. Well, let's plot out some other points and we'll see. Because times 1 wouldn't really work. Times 1/2 would work. We said 2 times 1 over 2 minus 1, you'd get 2 over 2, which is equal to 1. And then you get 1 minus 1, which is equal to 0. So we're kind of going 1 over 2, which actually is our slope. And I'll demonstrate that in a minute, but here. So that would mean x is 1/2. So if x is 1/2, that's kind of back here, okay? Okay, and this is our dot here, okay? On 1/2 of that, okay? Now this isn't perfect because I don't have any graph paper, so yeah, here we go. We can do higher numbers. We can say 2 is equal to, fx of 2 is equal to, I'm going to say 4 because 2 times 2 times 2, and minus 1. 4 minus 1, we're going to say f of 2 is equal to 3. Okay, so now we get this. This is 2, 1, 2. No, wait, no, this is 2. The x is 2, and this one is 3. If this looks like it's bending, it's not. It's just the way it goes. So now we have this line. Magical line. Oh, but as a result, we can plot this one here. What is this one? Let's see. Well, x is equal to 1. Okay, then we get 2 minus 1, which is also equal to 1. So this is 1 and 1. This is where we intercept. So this is the x-intercept. And this is the y-intercept. Okay. We can plug in other things into this besides the intercepts, like I showed here with 2, and with 1. See, 1. Now we can demonstrate the slope, which I said was 1 over 2, which makes sense because that's where it hits on the x-intercept. But pretty much here we have exactly that. We have 1 over 2. Well, actually, never mind. I don't think that's our slope. Let's see. Is it run over rise, rise over run? Let's see. Last I checked, it was rise over run. We actually have 2 over 1. No, we don't. Yes, we do. The slope is 2, so never mind. I got this confused. This is not the same as this. This is 2 over 1. Rise over run. I don't know, y over x. However you want to do it, but this is our slope. I'm actually not entirely sure how to use slope. Like, I know what it is, but I'm sure I'll know this later on exactly what slope is. But really, the length is relative. Because technically we could do like I'm going to do the Pythagorean theorem. Let's see, 1 squared plus 2 squared equals x squared. Then you go 1 plus 4, 5. Yeah. Yep. So, and this is obviously not equal to 2. So slope is definitely different from the Pythagorean theorem. It's not a measure of length exactly. It's a measure of something else. But I'm not exactly entirely sure quite yet. But yeah, there we go. I'll give you one more point. Actually, I think it's good for statistics, I think that's what they use it for, now that I remember doing some statistics. Here we go. So let's do this one. So I want to make this equal to this, probably 3. Let's do this. Let's do f of 3. Plug this into the equation. This is the fun part. You get to map it. You get to do all you want with it. Oh no, I didn't realize I was putting it over there. Okay, -1. Okay, 6 minus 1, which is equal to 5. Which is 1, 2, 3, 4, 5. Right where I predicted it. I know, it is exactly as I have foreseen. But yep, there we go. That's all you need to know about slope, I guess. Rise over run, y over x. The number of spaces upward is 2. Number of spaces sideways is 1. So we get 2 over 1. Okay? 2 over 1 is 2. Now this may be harder on some cases where I were to say, like, what if the line is like this? And so when you take it, it's like this, then like this. Okay, and then up is 2, but side is, we'll say that's 3. Okay, so then you get rise over run, you get 2 over 3, and that would be equal to 2/3. That's what 2 over 3 equals. And it could also equal, if you want to be super crazy, you could just write as many 6s as you want, or you could be simple and just kind of do this. But yep. There's your answer. That's how slope works.